All right. Further establishing myself as the person who can only talk about baseball. I decided to do my presentation, my final project on a league called M&S Softball. What is M&S? M&S Softball is a league many of my friends play in. I've also been unofficially involved in this league. They use a draft system, as you can see here. This is a draft from a number of years ago to choose teams each year. So I want to use my model to predict player production in order to give the user the best chance at picking the best players. My data set is the rows of my data set are each individual season from in the league history from each individual player. So that's basically what their stats were. So I'll get the target value. I'm sorry, the target variable I'll be using is a stat called WOBA, which stands for weighted on base average. It's basically a metastat which gives a weight to each offensive event, walk, single, double, triple, home run, and then divides it by players' number of player appearances. That doesn't really matter. I just want to be specific about it. And here's an example of what WOBA from my top 10, the top 10 on the list, not 10 most, but the 10 from the top of the list would look like. All right, my feature variables I found using the career stats of the players up until that point was the best way to go for predicting their future production. I'll also be including stats from other leagues with a lot of crossover with this one. They're called YMSL and MSB. Fine, that's these O means other league, and then this O league is 0 for YMSL and 1 for MSB, just to clarify which is which. It might not be the best way of going about this, but I needed a certain number of data points, and this seemed to be the best way to get that. Lastly, I'm also including the year, so that's the 2021 here. And again, as I mentioned, which of the other leagues the players also played in. So whether it's these stats would have been from YMSL or from MSB, and that'll be signified over here. Okay. I found the most important features to be year. So I guess the dynamics of the league changed from earlier to later. So the year was a big factor on base percentage and slugging percentage from both M&S and the other leagues. Since on base percentage and slugging percentage were highly correlated, as you can see, as the 0.9 correlation, I found that using extra base hit percentage, which is basically if you just bucket doubles, triples, and home runs in one bucket and then divide that all by plate appearances, amount of time the player came to bat, and you gave that a percentage, that worked better as a standard for slugging percentage when I was already using on-base percentage in my model. So I ended up finding that using a blend of linear regression and random forest, I averaged them two out. I weighted it against the scores. The random forest had a better score, so I weighted those results more towards the random forest. But I found that using this meta model, this blended model of linear regression and the random forest yielded the best results. It was an improvement over using either one individually, if only slightly. As you can see here, my linear regression had a mean squared error of 0.0060. Now, these numbers are really low, but you have to realize that the target variables are under 1, and they tend to be close anyway. So the differences are going to be not that much of a difference. Had a mean squared error of 0.006060, and the random forest was 0.00559, and it's slight improvement on the meta model, but still was improvement. So I figured I may as well use it. The mean squared error was 0.00556, and similarly in the mean absolute error, my linear regression model had a mean absolute error of 0.06419. My random forest had, as you can see here, right, 0.05912, and the meta model improved on that random forest number. Again, if only slightly, it did improve on it. So here are my results. As you can see, like 2017, Salim Levy had, a 0.380 predicted, and he actually had 0.350. 2015, Jimmy Kassab, 255, 245. They're somewhat close. Some of them are not as close, some of them are pretty on the nose, which is expected, especially as these are local softball leagues that the sample size is really small anyway. So what they actually ended up doing may not even be representative of their what their actual talent says that they should have done. All right, goals: win the M&S Cup. But how would we measure success to get to that point? Success would be measured in total team runs scored. More runs scored should lead to winning games. Winning games would hopefully lead to making the playoffs and hopefully winning the M&S Cup. All right, the next step, AKA, but first, maybe I can build a model to predict the stats of new incoming players who don't have a history in the league for me to work this model on. Next, I can find a way to evaluate players on other parts of the game, like defense and base running. 3, and this one is very important, I must come up with a cool team name. 4, I can maybe try to build the function in Python, and this is maybe a bit much for my current abilities, to help with drafting players by comparing who's available at what position at this point in the draft and who will be available at my next pick based on a simulation in Python. All right.
All right. Thank you very much, Charlie. That was an interesting presentation for sure. That's a great job. A few questions. You mentioned that you had kind of data on each player for like over different seasons, and you were using like a history for a given player to kind of make like the historical like career stats for a player to make a prediction for a given year. And you're only looking at the career stats prior to that year. So when
Yes.
you did like a train test split, did you do like a randomized split, or did you kind of split it on like a time-based approach?
No, it was random. It was all randomized. So I didn't I used a regular train test split, and so yeah, I used a regular train test split with everything just in the data set like that. I didn't split it in a specific time.
Okay. One thing that I would maybe recommend doing is to do like to kind of sort your data frame, to sort your data in like by time, so that you have like the oldest season like first, and then the newest season, the most recent season at the bottom, and then to like split it, just do like a straight split without a shuffle based on time. The reason for this is because like currently, like as it is, like you're kind of using like the career stats. I guess you're still only using career stats from prior to a given season to do the calculation, I guess. So maybe it's still fine. Because generally though, when you have like time series data, you kind of want to do like a time, like a split, where you sort it, like I said, and kind of split it based on time. Because in theory, like you could have samples, like you're including like samples in like your training data that contain like information about like newer years than maybe some of the samples that are in your test data. So it can be like a little, it can get a little fuzzy there. So that would be one thing I would maybe recommend. Let's see. Another question I had was you showed the scores that you got for your mean squared error and your mean absolute error for your different models. How do those compare to like your baseline scores?
Off the top of my, I mean, I didn't, so like a null model, you're saying, let's say?
Yeah.
So the actual, well, I didn't run the null model, but I checked the scores, the R squared scores, and there were again, for something like this, I don't expect to get a high score because of, I don't know, because of, again, the small sample size and things like that. Those were around 0.3 point, depending on the linear regression and or the random forest, 0.3s about low 0.3s. So, and then I didn't run it through to get myself an R squared for each one, because I didn't do the dummy model necessarily, but individually when I ran it and I got myself the R squared scores, they ended up around like 0.3 something.
Okay, yeah, if you get R squared, then you don't need to do the like dummy model thing, because it's kind of, the R squared is already kind of incorporating
so I
the
did-
dummy model score.
Right.
So yeah, I mean, you don't necessarily need to have like a 0.9 R squared to have a good model. I was just curious as to how, like, where we were at. So
Yeah,
like
no,
your model is doing better than the null model is really all I was asking.
I did that first just to calculate, because after I put them together, it was much easier just to calculate the mean squared error, mean absolute error, than get myself the dummy model and get myself find the R squared, just to compare them to each other. That's why I did it like that. But the whole time I was really working with R squared. So if you see in the technical, I'm working with R squared, and just at the end, I was just to compare them to each other. I checked mean squared error and mean absolute error.
Yeah, that's fine. Another thing that I might recommend is, so generally for like regression problems, one thing that I'll do is at the kind of, once you have like your best model, I'll show like a plot of your residuals. So either like a plot of your predicted values versus the actual values, or a plot of like the difference there versus the actual values. That way you can kind of like see if like you're doing better at like certain values than others. You can see if there's any kind of like trends. Generally, an ideal residual plot would be if it would just look like kind of random points scattered around zero. So you would have like no trends. They would be relatively small, ideally. That generally, that's one thing that I like to do a lot of times when I'm doing regression problems. So that kind of is, I guess, a general recommendation for everyone doing regression problems. Then the last question I had was, you mentioned about potentially being able to like predict stats for like new incoming players. How would you go about doing that if the players didn't have like?
So I'd have to get data from other places, right? From whatever, if there was a pipeline for a minute or two, they actually had a minors version of this league, or I would have to, or if they have, if they have played in other places, I would have to figure out individual, solutions. But in theory, what if I would want to build out a full, prediction for the upcoming season? I would need to either give myself at least a baseline, just average out rookies, like how their offensive production, and just give it to them, and just say, okay, this is what I expect any rookie to do. Or I can, if I can potentially get that data from other places and then run a model on that, then I would do something like that.
Okay, that sounds good. Any other